Good evening, everyone. So let me try this problem. This is JEE 2020. Have a look at the problem and then we shall start. S be the set of all complex numbers Z which satisfy this equation. Which of the following is are true? Very quickly I look at the four options and I realize that the option first and third, they both deal with distance of Z from minus half. Option B, distance of Z from 2, and then it's the number of this thing. So to begin with, what I would have done if I were in your place, I would have tried to understand this expression, this equation, and this is basically mod of Z minus omega into mod of Z minus omega square is equal to 1. Now omega and omega square are basically minus half plus minus under root 3 iota by 2, and minus half is the point from which these two distances are dealt. So this gives me a reason that I should start thinking of drawing a diagram and try to analyze that how these distances work. So what I do is I initially start with the unit circle, which basically would carry Z and Z bar. Then I take the equilateral triangle, which would initially take the complex number omega and omega square. So I try to plot. For me it is easy because I'm using this board. For you, of course, you will take some time to do that. So let me say this point is 1, this is omega, this is omega square. Let's name these points. This is K, this is probably B, this is A, and let me call this point as C and this point as O. Now, when we talk about options A and C, the first thing that I see is that they are dealing distance of Z. So let me say somewhere I take a point Z from these 2 points A and B. So I try to connect PA, which is mod of Z minus omega, and PB, which is mod of Z minus omega square, and I have my result in terms of geometry that PA into PB is equal to 1, and I am supposed to comment on it the distance of C from Z, that is PC, because that is mod of Z minus minus half, that is mod of Z plus half. Let this point be P. So I realize that in this particular triangle, C is the midpoint of AB by symmetry, and hence PC is the median of triangle PAB, and which implies that at the rate Apollonius theorem, you have done this in class 10th itself, sides squares add up PA square plus PB square, twice of the median square PC square plus half of the third AC square or BC square, whatever way you call it. So this is my first result that I will use. The second one, I realize that this very PA square plus PB square as an inequality is always greater than equal to twice PA PB. You call it basically arithmetic mean is greater than equal to the geometric mean or the perfect squares, whichever way. Now what I'll do is I'll plug PA square plus PB square from here and PA PB from here. So I realize that 2 times PC square plus AC square, which is nothing but root 3 iota by 2, the distance square, that is 3 by 4, is greater than equal to 2 times PAPB, that is 1. This is sufficient for me to say 2. If we cancel, we get PC square is greater than equal to 1 by 4. So PC is greater than equal to 1 by 2, which means option C is correct and A is incorrect. Pure geometry, 3-4 steps, provided you recall it at the right time. The second option to be tested is whether mod Z. Now let me introduce mod Z into the picture. So to look at mod Z, I join O with P because that's mod Z, and geometrically we don't go ahead much. Only thing I realize is that mod Z as an OP distance cannot grow infinitely, because if I take P2 up far away, then product PA into PB cannot be equal to 1. This is my sufficing working. So what I do is I realize that if I take a circle of radius 1 with center A, as long as PA lies inside the circle, distance PA is less than equal to 1. Simultaneously, I think of a circle which is basically of radius 1, and this time the center is B. So as long as Z lies inside this circle, distance PB is 1. Z cannot go outside this figure which looks like 8. I'm talking about this union of these two circles. Why? Because the moment it does so, both PA and PB become greater than 1, and then product PA PB cannot be equal to 1. So that means Z has to lie inside this figure 8, and this is the point O, which is one of the points of intersection of those two circles, for the simple reason that these two lengths were 1. So that means the maximum distance that P can be away from O is when P is diametrically opposite to O, and in that case this distance is basically 2. Hence this is sufficient to conclude that OP, the magnitude, cannot be bigger than 2. It has to be less than equal to 2, which is mod Z. Hence your second option becomes correct. I repeat, P if goes outside this figure which looks like 8, that is union of these two circles, then both P and PB are bigger than 1 and this product cannot hold 2. As an extreme case where the distance of P from O is maximum would lie either here or diametrically opposite here. Like, now coming to the last option, has exactly 4 elements. This doesn't make sense because any P which is inside this figure of 8 and satisfies this option, that means distance from this point mod Z minus half is bigger than half, would satisfy, which are much more in a continuum as an infinite. So this option definitely is ruled out. So geometrically speaking, this is the answer. If we were to try some algebraic identity, then it was more intuitive than geometry. So I believe this probably should be the solution which you should be trying in other such questions if they come across. Thank you for watching.